Hey everybody, welcome back, and we're going to take a look at an application problem here, and it came from a problem set that dealt with arithmetic, arithmetic and geometric sequences. You had to decide which one it was and then write a formula to make a prediction. And in some cases we had issues where we were letting in, f of 1 was our first term, and suddenly it turned out that we needed to be really careful with that line of thinking. And that it comes from this. All right. When we read this problem, Brooklyn opened a savings account with $1,300 that pays no interest. She deposits an additional $50 each week thereafter. And it says how much money would Brooklyn have in the account 50 weeks after opening it? All right, since this is an arithmetic sequence section, it's no secret this is an arithmetic sequence. Right? She's going to be adding $50 every week. So it's an add. It's not geometric, right? And but here's the problem we're going to have. Since we're dealing with time, and that's why I wanted you to look at this as a linear function, or even an mx plus b is fine, right? In this application, because mx plus b's have a nice feature. Okay, and I'm going to show you what I'm talking about. Let me pull this pad up here. I want to show you this first. Now we're dealing with n f of n, and this person starts in week 1. Now n is number of weeks, right? That's important that we define that because it's time. It's going on and on and on. And actually, this $1,300 we're looking at, if you'll take a look at where that's coming from, this $1,300 happens before a week is over. That's what she puts in sort of like at time 0. So that's one of the issues. After a week, if she's making deposits of $1,300, after the first week, that's in, 1 week has passed, there's $1,350 in there, right? In the second week, there's $1,400. The third week would be $1,450, and so on. We could keep on going with this, right? So what we might have to do is say, well, we might have to back this thing up since we have a context with time and say, well, there's sort of like this week 0, which means no time has passed. And I know I said when you're counting objects, you don't start with 0, right? These are natural numbers. You go 1, 2, 3, 4. You're counting desks in a room. You don't start on the first one and call it 0. You wouldn't get the right number. But with time, there is a 0 time. That's before you started counting it, right? The initial time. A lot of times the word initial is used here. So initially, there's $1,300, right? And we'll call this an initial amount. And when I teach the f of x, the function stuff, I teach it like this. There's an mx plus b. And m is your rate of change. And b is an initial amount. Let's see if I can get that thing spelled. That means some startup amount. How much did you start with? Right? Before you started counting time. That's what I wanted to come at you with. Now, we have adjusted this one like I was talking about in the lesson today. We've already adjusted it for these issues, right? So it would work out for us. But watch this. If we use our formula, our f of n notation, right? This is a sequence. We say f of n equals the first term plus, what is d? 50, right? We know that it's changing by 50. We could calculate that really easy, but we can tell that it's 50. And it's going up, so I have a positive 50 here. I'm going to use n minus 1 here. I want to show you what's going to happen. When we clean this up, and we should clean it up, 1350 plus 50n minus 50, watch what happens. We get this nice little formula, which is 50n plus 1300. Now, This is the same as if I'd said it's got a rate of change of 50, x start at 1300, right? It's almost easier to write it this way because we don't start thinking about n equals 1 and 0 and all that. So if it's linear, I would suggest maybe thinking about it, look for a rate of change, and then you have an initial amount. Where do we spot rates of change? Well, I don't want to go on and on too long here, but I wanted to show you how you spot the rate of change if you know that it's linear. Right here, each additional week. It could say per week. Those are indicators that we're dealing with a rate, right? And now look, if you put in week 0 start amount with this function here, like initially no time has passed, it wipes this term out and you get your 1300, right? Now, not to beat this to death too long, if we had started it with this being your first term, right? If we'd let that be the first term, this function would be off. It wouldn't be giving us this. Because we know this is time after 1 week. This is at the end of 2 weeks, the end of 3 weeks, and so on and so forth. All right? I think that I hope this is helpful. I know it's going to be helpful for the next unit. And anyway, thanks for watching, and be safe.